Alright, so this is the presentation for our line following robot. This is for Alex, Grace, and Kyler. So we started off by talking about our sensors. We bought a package of sensors, and we only used 2 of them that we bought online. They are just like the light sensors that we got in the kit, except for these will only output a 1 if they see the line and a 0 if they don't. There's also a potentiometer that you can see right here that helps you adjust the sensitivity. So for marking, we decided that we were just going to put down a piece of electrical tape using 2 arms, and there are servos hidden right in here that just place the piece of tape down, and we have a code set so that as soon as it sees that black line, it will just stop. So for the calculation of distance, we did a counting variable that counted our number of steps, and then we based that number of steps into how many were in an inch, and then that distance was displayed on our LCD screen. So this is just a flowchart showing our sensors and what they were going through each time. So if the left and right see white, then both motors would take a step. This is how we found the line. And then if either side saw the black, the line, then that motor that did not see it would take a step, and then if they both saw it, then it would set the motor speed to 50, and it would keep adding the steps until we got our total number of steps, which would then be calculated into our distance. So the takeaway from this, that if we were ever to do this project again, we'd probably work harder to find days that everyone is available to meet together, so that would make everything go smoother, such as coding, building the robot, knowing that we're all on the same page, which would help with making our testing happen sooner, so then we could work out our small bugs and everything that involves that, and we could probably end up making our code and make the algorithm both run smoother, and then we would have if we would have had more time and realized how difficult it was to fit all the components onto the breadboard, we would have used another breadboard as well, or another Arduino board in general, and that we would need a bigger chassis for. So then here are the links to all of our videos, and I'm going to just show you a couple. So this is the line following video, or finding, I'm sorry. So there's that, and then here is how it marks and follows the line. You can see that it dropped the tape, and then it continues to follow. Alright, so then here is our trial run that we did during the exam section. Alright, so it's straightening on the line, and then it is going to place the tape down and follow the line. And once it gets around this corner or two, you will be able to see the LCD display that shows the current number that we have, which was off with our calculations, but it shows the number that the robot was currently calculating for the distance. Alright, so you can kind of not really see it quite yet. Robot kind of stalled, got a little stuck on the paper, or a little spoon got stuck. Alright, so now you can kind of see it says inches with the wires in the way. If you look hard, and I think it's at about 20 something currently, because I know that it ended at about 37 inches. And it's going to do this last corner, and then it sees it and it stops. And I zoom in and I'll show you that it says 37 inches. Alright, so a couple things that I want to touch on quick is that for our robot, as I said, we ran out of board space, so we ended up not putting the buttons in. We didn't have any ports left open because the LCD takes up so much, and we had 4 motors running at all points. Just so we would have obviously added the other board and used that to help us with adding in all of the components that we needed to add. We would have changed our marker design. We found some issues with this as it tears off the paper when you're trying to remove it, and it's just not the best system, but with the time being, we found that the marker wouldn't be a dark enough line to stop our robot completely. We could probably figure out some sort of algorithm to just make our line start making better. Our vehicle design, I feel like this was a pretty solid design for a single breadboard mechanism. But if we were to add another breadboard, then it would probably have to be a different design and bigger. And I think we wouldn't probably have that spoon as the back support, as you can see a little bit right there. We probably would have done something more like a rotating wheel as the end part of it, but we did not have enough time to invest into that. Yeah, we just would have done a lot more little things to modify our vehicle. And just to touch on, so for our vehicle, as you can see, the chassis here is 3D printed, and we calculated that, and the 3D printing of this chassis costed us roughly about 80 cents, I believe is what they were saying. The spoons and stuff that we used like that did not cost very much. I mean, they were spoons that we got from like the cafeteria, so we didn't have to really pay anything directly for that. The tape, I'm not entirely sure. It was probably at most, for our adhesives that we used, was probably at most $5. That brings us up to almost $6. And then for these sensors here, we spent, I believe it was $6 for a pack of 10. So it would still be in our under budget. We are still looking pretty good. So that's all I really have to say about our vehicle.